Hey guys, and welcome back to the Coder's Legacy channel. In this video, we'll take a look at a rather interesting concept called name mangling in C++. Now, name mangling is a pretty interesting concept and it's something that a lot of people don't really know about. It's something that really happens in the background. You don't know it's happening, and honestly, you don't even need to know. But it's one of those things that really helps you build up your concept of C++ and how the compiler really works in the background. And there are actually one or two scenarios where knowing name mangling can actually help. Okay, and in today's video, I'm actually going to show you actual place, an actual use, an actual application where name mangling, where you need to know about it. Okay, where if you don't know about name mangling, you're going to run into an error and you might face problems. Okay, so there's some very niche situations where you need to know name mangling, but generally speaking, it's just something that helps you build up your concept. Okay, knowing how things work, how the C compiler works, how the C++ compiler works, how it really treats the function names behind the scenes. And you also get to find out something rather interesting, which is how does the concept of function overloading really work. It helps you understand the concept of function overloading in even greater depth. Before we start talking about name mangling in detail, let's talk about some prerequisite concepts. The first concept I want to discuss is function overloading. Now, I'm sure most of you already know what this is, but let's quickly go through it. So here you see this function. Okay, it's called func. It takes a string as parameter. All right. Now, if I create a different function over here, also called func, and it has no parameters, and I do this, is this going to throw an error or will this run? Well, it's actually going to work because there's a concept called function overloading that actually allows you to have multiple functions of the same name. Okay, and when we actually call them, if I call func over here, C++ will know that this means this function because there's no parameters. On the other hand, if you do something like this, then it's obviously going to call this one right here because it knows it'll match the fact that there's a string over here and it'll match it to this function. Okay, so that's the concept of function overloading. But here's an interesting thing. C++ supports function overloading, but C doesn't. Just remember this fact for now, okay? I'll bring it back up once we discuss name mangling. Okay, so this is the first thing we've discussed. We've discussed how this really, concept works, function overloading, okay? But here's the thing. There's a concept, there's a rule that must be followed. Every entity must have a unique name, okay? But here we can see a contradiction. These two functions have the same name, okay? Now the compiler needs to have unique names for each of these functions. Okay, otherwise it'll get confused. Okay, you need to logically come up with a way for the compiler to differentiate between these two functions. So how does that work? How do we keep the concept of function overloading yet also fulfill this rule that every entity must have a different name? Well, that's actually where the concept of name mangling comes in. Okay, you see, your function name is never actually kept the same. Behind the scenes, in the eyes of the compiler, your function is not actually called func. Okay, that's not what it is. Behind the scenes, it's actually a bit different. Now, the exact process, okay, this is what we actually, that's what name mangling means. It's actually a word. Mangle is a word in English. It just means to kind of mess around with it or modify it. And in this case, what we're modifying is the name of the function. Okay, so how are we modifying the name of the function? Well, we're actually adding in some extra information to the function name, and that generates a unique name. Okay, now let me elaborate on this. Now you see this function over here. Let me show you what it might look like after name mangling has been applied on it. Okay, now once again, the exact way name mangling takes place varies a bit from language to language and from OS to OS, I think, and version from version. But I'm just trying to give you the concept here, okay? You don't need to actually know what happens in the background, okay? Unless you are trying to create a compiler, in which case you could just define your own rules. You just need to know the concept of name mangling and why we use it, Okay, so basically this function over here, what it might look like behind the scenes to the compiler is something like this. Okay, underscore v. What does that mean though? Let's just use comments over here. Okay, what does this mean? Well, this actually means that this is the name of the function, then there's the underscore for some spacing. Okay, this is again just format specific. It depends on which compiler is doing the name mangling. Okay, some compilers do it differently. I think there's an entire page on Wikipedia. You can go check that out. It shows you an entire chart of different types of name mangling. Anyways, so this v, what does that stand for? V stands for void. Okay, this means a function that is void. Okay, this is the name of the function, and this shows that it's void. It takes no parameters. This here is a unique name. And how is it mangled? It's mangled because we added in this extra information to it. Okay, now let's come up with the name mangled version for this function here. Okay, can you guess what it might be? Well, it's gonna be func, the name of the function. The name of the function is always there. Okay, we just append some extra information to it, and that information ensures that it's unique. Okay, so in this case it's going to be underscore s. Okay, now look, these are two unique names. The compiler can now differentiate between the two of these functions. Okay, this is how name mangling works. This is what it does. It generates unique names, unique IDs for these entities. Okay, now let's just create one more function. Okay, I'll create one more function and show you how that works. Okay, so let's say this also takes an integer. Okay, it takes a number as well, and we just do this. Okay, what might the name mangled version for this function look like? Well, it's going to be func underscore s and then I. Okay, I for integer, s for string. Okay, and of course the order matters. So if you have a string first, then the s will come. Then if you have an integer, then the I. Okay, so again, even though it looks like to us that these three functions have the same name, so even though it looks like to us that these three functions have the same name, they actually have different names in the background because of name mangling. Okay, and this is a concept that goes hand in hand with function overloading, because without name mangling you can't really do function overloading. Okay, I mean, you could come up with some kind of alternate technique maybe, but this is just the concept that's used for function overloading. Name mangling enables function overloading. Okay, now the thing is, the key point here is that earlier I said that C does not support function overloading, and guess what? Because it doesn't support function overloading, it doesn't support name mangling, or more like it's the other way around. Because it doesn't support name mangling, it doesn't support function overloading. So in C, this is a CPP file here, by the way. So if I converted this to a C file, you would actually see that it would not work. Okay, let me just actually run these and just show you. Okay, I'm going to call func over here, and then maybe we'll convert this to a C file and then try it. Okay, hello world. Then we'll call the last one number, and we'll pass in a random number like 20. And hold on, it's a typo. So if I run this, what's up with the terminal? Come down here. Oh, there's a semicolon missing there. This is gonna throw an error. Alright, so here's our output. Hello world is printed out twice because this function also prints out hello world. I should have changed that. I forgot about that. Well, whatever. But we see the point here that these three functions were called and no errors were thrown. On the other hand, if I change this to a C file, I mean, that would be too much trouble. We'll need to change all these statements then. But the point is, in C, you can try this out, try the same thing, it won't work. Okay? C doesn't support function overloading. Now, in today's video, I did promise that I would show you. Now, I did promise you that in today's video, we would discuss an actual use of, or more like an application where name mangling, where knowing the concept is actually important. Okay, and that's actually something to do with this Python library called C types. Now I know this might seem a little off topic, but this is something I just want to show you guys anyway. because you don't need to know what this is, what this Python library is. I just want to show you that there is some kind of use for this. Knowing this can actually come in handy, and I want to show you how exactly the difference between C and C++, that one of them supports function overloading, one of them doesn't. I want to show you how this difference really affects our code. Okay, and there's one more command, an important statement that I need to discuss. Okay, and I can't really discuss that without showing you this Python library here. Okay, so without further ado, let me just quickly explain this. What I'm doing here is using this Python library called ctypes, which we can use to call functions from C and C++ libraries. Okay, so what I'm going to do is actually G++ and FPIC shared. What I'm doing here is basically generating a shared library. Okay, again, you don't need to know exactly the technical details here, but if you are interested in this concept, if you do like to program in Python, then do check out my ctypes tutorial. We have discussed it in quite detail, several videos on it. It's a pretty complex topic and a pretty interesting one too. I'll have some links down in the description below. Okay, so yeah, do check that out. Okay, so here's our shared library generated. You can see it over here. The shared library is basically what we import functions from. This is the path to that shared library, and now I'm going to call those functions. Okay, oh, and I actually have this file here called clibrary.c. Okay, this is from when I was previously working with ctypes. Let me just create a function over here as well. We'll use both the C++ library and the C library, and there's something I want to show you. Okay, so I'm going to do printf. Okay, C doesn't have C out, so this will be hello world. Okay, and I'll create another one, and this takes a string, okay, or a char string, because as you know, C doesn't have strings, not exactly. So here we go. All right, so what happens if I try to compile this? This is what I mentioned earlier. C doesn't support function overloading, right? So what happens if I try this command? Okay, I'm going to try to compile it using GCC. Okay, I'm just doing this through the terminal. You may do this through, the GUI. Okay, just doing this, changing the extension, and let me run this and see what happens. It's going to throw an error, okay, because it will not compile. There you go. You see, it says redefinition of func, because it doesn't accept the fact that they're different. Okay, in C's eyes, both of these functions have the same name. Okay, so it just sees you as redeclaring a function that's already been declared instead of creating a new function. Okay, that's just what I wanted to emphasize on. Okay, and now I'm gonna come back here, and I'm actually going to first use the C library, because right now we have two shared libraries. I've generated a shared library for this. Oh wait, I haven't actually. Let me run that command again. It's gonna work this time because I removed the conflicting function definition. Okay, so now we have two libraries, one for C and one for C++. Okay, there's something I want to show you, something really important. Watch, print, this is just how you access these functions, C library dot, and then the name of the function. So right now we're accessing our C library, and it has the function called func. So if I do this and I run it, it's going to work. It should print out hello world. Yes, it printed out hello world, and also a 1-1. I think that's to do with this for some reason. Let's just, oh, of course, because I don't need to print it out, of course. So if I just do this, then hello world is printed out. Okay, the C library is working. Okay, note that. Okay, and now let's move on to the C++ library. Let's try to run the C++ library. So I'm going to try to call this function over here. Okay, I'm going to try to call func. So if this works, it should print out hello world. Okay, look at that. It's not running. It's not executing. Why is that? Why is it saying function not found? Well, this is actually where we need to understand name mangling again, because you see the C types is trying to call a function called func. Okay, now the problem is that it expects to receive a non-mangled name. Okay, and this is something you'll come across in other scenarios as well. Okay, it's not just, when you're using this with Python's, this specific library. There are actually scenarios I've heard about where people are using C and C++ together in the same program, and you're trying to call a C++ function from the C code, and then it gets confused. The C compiler gets confused because it's trying to call this function called func, but it's saying function not found. Okay, and why is it not working? Why is this function not working? We can clearly see that there's a function called func over there, right? You might think that you're calling func and func is over here, but it's saying function not found. The reason for that is that the actual names are function.v or something along those lines, and underscore, and function_si. These are the actual, wait, hold on, this is S. Yeah, these are the actual names. Okay, so when the C compiler calls these functions, it knows to mangle them. It knows that they're mangled, so it'll act accordingly. But the C calling convention, it doesn't expect this, so it's going to try calling func, which doesn't exist. None of these are called func. Okay, func, none of them are called that. So that's why this is going to throw an error. And this is actually, I totally forgot about this, but again, when you're using C and C++ code together, and this is often when you're maintaining legacy code, you need to keep this in mind. Okay, that when you're using the C compiler, because this is the same thing. Okay, C types is basically, you're bringing C data types into Python. Okay, same thing. It's a very similar scenario. So this is actually a problem. And how to fix this? Well, the obvious solution, and which is the only solution really, is to disable name mangling in C++. Okay? Oh, I'm not saying you need to go and change something in your compiler settings or something. No, it's actually a built-in command that we have. Okay? And of course that means we can no longer do function overloading, so I need to delete all of those. Okay? And what you do is use this, extern C, and you put everything within the brackets. What this does is says this is basically external C. It means that this is being used externally as a C function. So now it knows that this function knows, okay, it knows I'm supposed to be a C function, not a C++ function. So I will not perform name mangling. Okay, now let's try recompiling this, and I will now run this, and guess what? It prints out hello world. It's working now. Okay, so this is the, oh, hold on, I deleted that. Okay, so this is the concept of name mangling. Okay, and I just showed you there are actually pretty much two main aspects to name mangling. What is name mangling and how to prevent name mangling? Okay, these are like the two most searched terms about name mangling, because most of the time when people want to know about name mangling, it's usually because they want to prevent it from happening, because they're in scenarios like this which I just described to you, they're trying to use C and C++ functions inside Python, and they're running into errors because one of them expects to receive a non-mangled name, one of them is mangling the name, and that's causing compatibility issues, or they're using C++ code in C code, and there's a conflict occurring because one of them is a non-mangled language and one of them is a mangled language, so that's causing problems. So these are the kind of scenarios where name mangling can occur. And yeah, I hope you guys learned something new today. I think I gave a pretty descriptive overview on name mangling. Hopefully you guys understood everything. If you guys like this content, make sure to subscribe. We have a lot more content coming out, a lot more Python libraries to cover, a lot more interesting concepts like this, C, C++, Python, and maybe even some other languages that we'll cover later on. We have a lot of stuff in the pipeline. Okay, so yeah, we'll end the video right here. See you guys in a later video.